Okay, so let us get started, and please continue to introduce yourself with using the chat. So we are here today with Jasper and me, of course, Reflow Filament, and director of the Illinois Maker Lab. Jasper, of course, is the co-founder and CEO of Reflow Filament, and he's based in Amsterdam. I think, Jasper, I might just mute to reduce the background audio from your side.
I have to sit somewhere else. Wait.
Okay.
Gotta find a better location.
Okay. So while Jasper relocates, I'll sort of give background on the call today. So Reflow, of course, is, as Jasper will tell you more, but they're a startup based in Amsterdam looking to convert plastic waste into 3D printing. And for those of you who have taken the or are taking the course, which is as part of our 3D printing specialization, you would have seen another startup based in India, Protoprint. I may have the name wrong, but you would have seen the startup based in India, which is doing a similar effort. And of course, that is in the context of using this new technology as an enabler for development and perhaps also for sustainable new manufacturing methods that we are experimenting with for the future. So this course that this webinar is sort of placed in is the second course in this specialization. And if you haven't already tried it, you can try the specialization. You can find us on 3D Printing Profs on Twitter, and you'll find our links to our website as well, which is simply 3dprintingprofs.com. And of course, the specialization itself is on Coursera. So back to Reflow and Jasper, and I will unmute Jasper in 1 second. There we go. So back to our our discussion for today. Thank you, Jasper, for taking the time to chat with us. Could you start with telling us a little bit about yourself, your background, and how did you land up in 3D printing?
Cool. Yeah. Thanks for having me, Sakdev. So my background, my study background is communication science. I did a brief stint in IT after that. Did a lot of volunteering work when I was in my student days and got into kind of the NGO area after that. So for a while, I helped NGOs open up their information, their data, in a standard called IATI. And I got involved in, well, it started more with thinking about social entrepreneurship than 3D printing, to be honest, at the start. So I got involved with a foundation called NVU in Rotterdam, where we worked on a project for diaspora to help with sending money back home and buy financial products for them. And kind of my work from NVU, that project didn't work out kind of funding wise, and NVU kind of asked me to stay on and look for new exciting kind of products. And I was like vaguely involved with 3D printing in the Amsterdam area, but more into the kind of recycling social enterprises. Okay. So I went to Kenya, for instance, for a bit, kind of look into different recycling opportunities there, and kind of the things you see and how recycling is organized, how dirty it is, what kind of jobs people have, how hard they need to work just to collect a few bottles and make a little bit of income. That really struck me, and we kind of got thinking about what's actually the most valuable thing you can make out of plastic, because the entire recycling industry now works on volume. So it means you get a lot of bottles and you sell them at a little bit of margin, and you try to make a business out of that. And it kind of worked for a while until the oil price started dropping really bigly. So a lot of these businesses, especially if they're focused on plastic, are going out of business. So really started thinking about what's the most value thing you can do. And I co-organized a conference here in Amsterdam called the Open Development Camp. And one of the speakers was William Hoyle from Tech for Trade, which I think was in the last course.
We interviewed him in the course as well. Yeah.
Yeah, so he has some really good ideas around kind of 3D printing and development, making filaments, and it kind of kind of started from that and pitched it at NVU. They had a collaboration with Cordate, so I got a year to really work on the project. Yeah, and that kind of grew from that. And so my background is IT, communication science,
Okay.
social enterprise, NGO, open data,
Okay.
3D printing.
Nice.
Yeah.
So Amsterdam seems to be sort of the hotbed for a lot of the 3D printing firms, right? 3D Hubs is there, Shapeways is there,
Yeah.
Ultimaker is there. And,
Well, Amstelmaker is in the east of the Netherlands, but Netherlands as a whole has been really big at 3D printing. Shapeway, so Shapeways was born kind of here.
yeah.
And a lot of kind of smaller 3D printing startup called Printer. So it's Leapfrog. So it's pretty big. So we're hoping to be be the next big one.
Good. Well, we hope you get there.
Thanks.
So tell us about, why do you think 3D printing is really, revolutionary, and, what is your view, particularly in the context of even, social entrepreneurship or development? What's the connection?
I think actually like 3D printing is somewhat revolutionary now. How is it being used? So obviously it's revolutionary in the airplane industry, in prototyping, in making cars and stuff like that. It's revolutionary with dentists. But if we really look into consumer facing products, it's very thin. And we actually think 3D printing can be the most revolutionary in countries where the infrastructure is most broken. If you really think about the problems 3D printing is solving around production, around supply, around infrastructure needed, about knowledge needed, about capital needed, all those problems are biggest in regions where kind of the production infrastructure is broken, such as in East Africa. And we always compare it to kind of what happened to mobile banking and solar. Okay. Not sure if everyone listening is familiar, but there's a really big mobile banking is really big in East Africa. So someone in Tanzania, for instance, is 3 times more likely to use mobile banking than anyone in the US or Europe. So kind of leapfrog because the entire banking infrastructure was broken. Like 10 years ago, only 30% of Kenyans actually had access to banking services. So that means 70% couldn't even save their money in simple financial services. And mobile banking totally changed that. Same with solar. It works because the energy infrastructure is broken. So the biggest solar companies are in East Africa. And I think the same could happen for 3D printing if we overcome some challenges. It's there where production is broken, quality of product is really low, import tariffs are really high, getting something from point A to point B is really hard. I'll probably talk a little bit more about the specific applications a bit later on. But just to give you an example, like some of the clinics we've talked to that do medical supplies out to rural areas, and it could be as simple as clamps or microscopes or whatever. Sometimes like 15 to 20% of everything that they try to transfer gets stolen along the way, or someone picks it up because it's valuable. Those are issues you don't even think about when you're in Amsterdam or in the US. But those actually it's not something like when you read about 3D printing, no one ever says, well, yeah, it helps. Like people don't steal it because it's produced close by. And those are the problems people are facing every day. Those are the problems clinics are facing every day in East Africa. So we think if we can get over some challenges in terms of quality, local resources, local capacity to repair, education, that actually the technology would work best there and actually matures in terms of consumer facing and small niche production there earlier than it would in Amsterdam or in the US, where at least for a few years it'll be limited to the really industrial applications that we see now. And even a company like 3D Hubs, you kind of see them slowly getting more into the industrial area because just that's where the 3D printing business is right now.
Yeah, I think we had of course, we had a chat with William Hoyle about, Tech for Trade and the 3D, 4D competition that they had done a few years back. And actually 3D Hubs was one of the applicants for that competition, and they didn't get funded through Tech for Trade then. So they're doing pretty well. And we had a chat with, the name is slipping me, but they have looking at 3D printing in disaster relief. Again, the same context that when
Field Ready, I think.
Field Ready, sorry, yes, Field Ready. And, when the supply chain is broken, how can enabling manufacturing locally with these, with 3D printing help address that gap?
Yeah.
So, in fact, in the course, our one focus is 3D printing for development. So that's where, and, maybe I think Nagarajan, I know, is in the course. I'm not sure. One of the viewers. He's always there in all our webinars. So welcome, Nagarajan. Good to see you back. I'm sure we have another project which is actually based in Tanzania as well,
Okay.
which is where they're looking at what's called marketplace literacy. So low income, low literacy learners being given sort of a background to make them smarter consumers or better participants in the marketplace, so that they can engage and find better, do transactions better in a local marketplace. And then we are adding on what we call maker literacy into some of these contexts. We're trying it in the US as well, in the rural locations, and Tanzania and Chennai. So that's
awesome.
It's called the Marketplace and Maker Literacy Project.
Cool.
So that's, sort of to give perhaps our viewers as well some more context on all the different applications that we've discussed so far. Jasper, before we talk about, Reflow Filament, and you tell us more about what you are doing, let's go in and from your experience, what you've seen perhaps in Africa or other countries, or perhaps what you've seen with your firm as well, is some examples of where 3D printing has helped in this particular context. 3D printing for development broadly.
I think we're more talking about where it can help than where it has helped.
Yeah, probably, yeah.
In Tanzania, we're working now with a local health clinic. We just got a grant proposal in on specific health-related things. So one, I think the most promising one in the short term is the microscope. So working with the University of Cambridge, they set up something called the water scope that is initially meant to kind of test waters, but it could also be used for malaria and TBC, early TBC detection. So we're working with them to kind of set those up in rural clinics, which has a few advantages. One is cost. So the current microscope they use has like $1,500. And we're looking at a Raspberry Pi model. What cost price would be at $160, probably selling price around $300, something like that. And you can actually send data over just over telephone line back to a centralized institution. So you can actually have like this decentralized network of production microscopes in a region, maybe even in a rural region. They can send it out to several clinics, which means they can actually do TBC and malaria detection close to their clinics, which is good for several reasons. One, people don't have to travel all across the country, which takes them 1 to 2 days, which for us seems like you get a day off and you go to the clinic. It just basically means people are missing 2 days of work, which is a big thing. But it also means you can actually repair things quickly instead of having something ordered out of China. So all these supply chains for health-related clinics or health organizations basically mean they buy stuff from China. It takes them 3 to 4 months, even for simple products, to get it into the country, and that's fast. Then they process it and get it into the rural clinics, which the distribution is really hard and really costly. Then if it's medical equipment that that are using, for instance, clamps, they need to get it back. And then they need to ship it to South Africa because it's medical waste and they can't process it in country. So this is a really complicated supply chain where we think 3D printing for some products can really kind of make a lot of sense. The microscope is the easiest one because for medical equipment, we see a lot of people like putting clamps on the internet and it being like open source, everyone can use clamps, but obviously it's a medical equipment. So you're not gonna you're not saying, oh, it's East Africa, we can use inferior quality products. You want 3D print is just a tool. You want exactly the same quality products in exactly the same approval period. So microscope, obviously, you just need to test on output. You don't need to test on the antibacterial stuff and things that kind of come with other medical equipment. But we're also looking into clamps and other applications, but that we're doing together with an organization called 3D4MD.
Okay.
I'm not sure if you heard of them. They're Canada-based.
No, I haven't.
A really awesome person called Julie Ling Wong is leading that. She was involved in the NASA kind of it's called I think the Mars project, something like that. So they had a dome set up in the desert, and they were kind of testing 3D printed related things as well. Nice. And she's really getting 3D printing approved as a process for Class 1 equipment by the FDA. And Class 1 is basically everything outside of the body.
Okay.
So that are those are longer term things because it needs 3 to 4 years to really get into this approval process, set up the distribution. But those things could really revolutionize the supply chain that these organizations have and cut costs by like a fourth. It is pretty amazing. But then like there are a lot of steps you need to do, a lot of challenges. But we think it's there where the technology can really make a lot of sense. And then there's like small things we're involved with the Reflow is like making tourist designs out of the recycled filament and just local empowerment, local jobs creations. The overall idea, of course, is if you're talking about 3D printing revolution, local manufacturing, empowering local economies, then it makes the most sense in East Africa or other developing regions because they import a lot of low quality products. And they export all their valuable resources, and that's how they work as a country. But what happens if you can actually start making more and more products in home, and what that does with the economy, with the jobs, with people working there, the way they work. Again, even in kind of urban slums, there are a lot of product needs people have that are not being met right now, just because it's produced far away or they're a niche or no one's really looking into their needs. Well, if you can actually produce kind of localized, then that makes a lot of sense. And then kind of that's a lot different from here in the Netherlands, where if we want something, we can get everything on order to our door. And if we order before 5, we get it 3 next day. So compete with that as a 3D printing company. So then kind of, obviously there's a lot of awesome applications 3D printing has, even in Amsterdam and in a lot of different countries, but really looking into big scale, like mass niche market, I think Chris Anderson called it, like the really getting production and a company up and running on specific consumer facing products that don't need personalization, are like East Africa makes the most sense. And that's one of the reasons why we're setting up production there, just because we think the market, with a little bit of help, we can have the biggest impact, but also it could be one of our biggest markets in hopefully 5 to 6 years.
Nice. Okay. Yeah. So tell us now, more about, Reflow Filament and your approach to, as we know, is converting trash to usable filament for 3D printers. Where have you reached so far?
Yeah. So we create industry quality filament, just to get us. So you mentioned usable filament. I think a lot of the recycling initiatives and extruders that are currently available make usable filament. Okay. Maybe for your own kind of printer, they don't make filament that can actually match a industry quality, and that's what we're doing. So we're really building an international network of local and empowering local makers to make their own recycled 3D print filaments. Okay. So in terms of technology, what we're doing is basically you have 2 types now. You have the big industry machines, really expensive, high expertise needed, and you have the home extruders, really inexpensive, but also lacking in consistency. So we're building something in the middle, basically taking everything an industrial machine has, but downscaling it. So it has a laser sensor, it has diameter control, it has a water bath, everything like that. So you can actually make industry quality filament, but at a far lower scale. So this enables us, one, to produce filament closer to the end market, but it also enables us, such as in Tanzania, to enter growing markets at a very small rate. So imagine you need a machine that produces tens and hundreds of kgs a day, and trying to set that up in Tanzania in a market that's maybe 50 to 100 kgs a month. Doesn't make any sense. But while you have like far smaller machines that are really flexible, you can actually do that in growing markets. And that's something, like, as a company, we really want to. We started off as a company that makes filament in 1 or 2 production facilities and exports it all over the world. But we're transitioning more and more into a franchise organization where we support local makers with technology, with branding, with quality testing. It's obviously a really important thing, with setting up the sales channel, with some finance, and really help them kind of take over the local market with recycled filament that is competitive in pricing as well as in quality.
Nice. Okay. So are you actually selling the machines, or you still own the machines on all the franchises that you put?
We're currently working on that. So we have 1 franchise location in Dar. We have 1 own production location setting up now in Delhi. Okay. And we're setting up Amsterdam in November. Okay. And then hopefully early 2017, US and South America. So we have 1 in almost each continent. And the kind of there's different models for different different countries. Like something that works in Tanzania, we'll pre-finance a lot more equipment, sometimes with grants or other kind of financing, than you do, for instance, if you start something up in San Francisco, which we maybe just lease the machine. We might sell it, but ideally, I think we'd look at it some sort of lease model. But it's something we really need to look at. We're still an early stage company. We started in kind of November, December.
Okay.
We're tech-wise like 90% there. We're producing the Kickstarter. So we did a Kickstarter campaign, and we'll be producing for Kickstarter in November.
Oh, nice. Okay. And in all of these, I guess controlling the quality and the supply for feedstock would be very important. So how do you help set those up?
So in terms of the, there's like different quality aspects that we need to measure. One, most important, of course, is the diameter consistency. So we've built in a laser sensor that just continuously tracks the diameter of the filament that gets in. So that's kind of the hardest part to do in production, but the easiest to check. Then you have moist content and other kind of impurities that may be in the plastic. So we're currently working on a testing process to test that. There's someone with a PhD in polymer science coming on board to work with us on kind of that quality testing process and material development. Then there's the pulling strength and the torque strength and stuff like that, and benchmarking that to existing filaments. And we're currently exploring opportunities to work together with the University of Oxford and a startup called Metascape, where they've made a open source, fairly cheap machine to test the quality of filament in terms of pulling strength and stuff like that.
Okay.
So it's a complex process, but it's manageable.
Right. And have you already established that the output after all of this will be competitive with, let's say, imports from China or some other low-cost supplier of filament, or
price or quality?
I would say both, depending on which one is which part is more important to the customer.
I think both. Well, quality obviously is most important to the customer, because like have filament that jams up your printer once, you're not going to buy it anymore. Yeah. That's my experience at the very least. Yeah. So quality is first. Yeah, we're confident we can get to a quality that's way better than a Chinese import. That is comparable to what you get out of a premium brand in the Netherlands or the US. Okay. And there's nothing, both in technology as well as in the recycling of plastic, that would limit any kind of quality. There's no ceiling on quality because you're a recycler. There's no ceiling on quality because you're using a different technology. It's just you need to get it right. You need to get downscale the technology in the right way and have a really, really thorough quality process. And that's exactly what we're doing. On the pricing part, so interesting enough, a lot of people think that 3D print filament, like plastic, for some reason, is like a big component of price. It is not. Even if the price would double over the next years, you probably not pay more than $1 plastic for a kg. Okay. Well, while a dollar like a filament, at least $25 for a kg. So the rest of the margin is basically distribution, organizational costs, marketing, stuff like that. And we're cutting out a lot of the distribution costs. Okay. So we're not producing in Amsterdam, shipping to the US, or producing in Amsterdam, shipping to Paris. We actually producing in Amsterdam, producing in Paris, producing in San Francisco, producing in Chile, and just selling it locally. And I think that's a big technology. We have a good quality product that we can manage over several locations, and it also helps build a brand that can actually work in different locations, because that's also kind of the filament market is really fragmented. Yeah. It is a producer here, producer there, and they kind of sell to the regional market. Yeah, best. And with actually making a network of local franchises, you can actually build a brand that's everywhere, hopefully. Yeah,
that's I think, given that the technology itself democratizes production, perhaps the source, the raw material, should also be available widely, and that will help it explode to some extent.
Yeah, I think what's happened with the 3D printer industry as a whole, like a lot of these parts just get cheaper and cheaper and cheaper and cheaper, meaning and patents expired, and then companies as Ultimate could buy a really good quality product at a 10th or 20th of the price. The same is kind of with the stuff we're doing in terms of extruder. Stuff like a laser sensor has gone down in like a tenth what it used to be 5 years ago. So like 5 years ago, we wouldn't have been able to make extruders at this price point that actually work at the quality we want. But now with all of these components becoming available to everyone, you can actually start doing industry quality stuff for at a far lower production rate, at a far lower economies of scale.
Yeah. Well, we're almost opening up for questions. So while we continue the chat for a minute or two, all the viewers, you can use the chat to start asking your questions, and then we'll take the questions from the chat itself. So go ahead and type out your questions. And so Jasper, just a last question from my side. Where do you see yourself or this industry that you're in? Because there are several initiatives. I mean, you talked about setting up an office in Delhi, and we spoke to the founder of Protoprint, who are trying out a project like this in southern India by again recycling trash and engaging the trash pickers into the supply chain.
Where did you talk to Sid?
This is the firm is Protoprint.
Yeah, I know the Tech for Trade, kind of William Hoyle mentioned we're also working with Protoprint before.
Okay.
I know they had some they're like really cool initiatives. So yeah.
Yeah. So I mean, in terms of looking out into the future, you can share your vision for your firm, or this industry in general. Where do you see it going 3 to 5 years hence?
So as I said, I'm hoping it'll be big in countries where production infrastructure is broken. I think that's one. I think obviously in this industrial applications will continue to be really big and will widen more and more. Okay. So there won't just be super high speed cars or really expensive cars and airplanes. It'll be in the industrial kind of manufacturing process of specific parts more and more throughout the industry. Okay. I think that's one of the biggest things. You obviously see the creative industry will grow a lot. I think in 3 to 5 years, I already see a really cool kind of fashion project coming out of there that always takes 3 to 5 years to go somewhat mainstream. So I'm really expecting the creative sector to kind of pick it up a lot more than it's been doing now. Obviously, they're not kind of used to working with technology, but just needs a few pioneers like Sylvia Hazel to kind of take it off and show what the possibilities are, and then slowly it'll grow into a mainstream fashion and creative thing. Artists, obviously, again, not used to these type of technologies, but it really could kind of change the way they make stuff and also change the way they sell stuff potentially. I think in terms of the filament industry, you'll see lower and lower costs with more competitors coming onto the market. You'll see more specialized materials. People hopefully will get more into using different types of materials. For us as Reflow, we're also looking into like PET as the start, but we're definitely going to look into ABS as a recycling, but also other types of engineering materials, especially if you support projects like the clams and stuff like that. It just won't do with PET. You need HIPS, but maybe other types of plastics as well. So we'll get kind of machines will be a bit faster, but I think there'll be like a jump 3 to 5 years down the line. There'll suddenly be a new technology that we'll all start using. That's maybe it's the clip technology from Carbon 3D. You probably have heard of. Maybe it's another type of technology we don't know. Good thing for us in terms of you looking at the consumer market. You can always look at industry and just kind of predict what happens in 5 years down the line, because things just don't get to the consumer market at the same kind of pace with patents and stuff like that.
At the industrial market, okay.
Yeah, as a company, we are we're really kind of transitioning into a big network where we have a small core team here in Amsterdam and really support local makers everywhere to kind of make 3D printing more sustainable, and two, make it more inclusive. So really get the big impact things out there, such as the microscope, such as the health, such as spare parts. Metal, like spare parts, obviously is one of the promises of 3D printing, not being done anywhere because metal 3D printing is really, really expensive.
Yeah.
But if it works anywhere, it'll work in East Africa. As everyone, kind of spare parts is a big thing here.
Yeah. 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 So we have one question from Nagarajan. He's from India. He says, how do you find places that have huge potential to produce trash and that actually can be recycled for this kind of machines for creating filament?
Yeah, so we're working with we have a few criteria we look at. One obviously is an existing recycling industry or existing recycling partners that create food grade or near food grade plastic, PET plastic for now, but could be other types as well. So for instance, Delhi is a really there's a big recycling industry there throughout India, of course, but then we look at what the kind of local maker, if there are parties that are really the local makers that know about 3D printing already involved in the community. So in Tanzania, we have a awesome group called StickLab. So sticklab.co.tz. They produce 3D printers made of e-waste. They are supported by Tech for Trade in making that. And they are a group of they make incredible stuff. I've seen them build a full water dispenser in like a day and a half, make their own PCB boards, put it together, weld it together, 3D print some of the stuff, and it's coin and M-Pesa based. It is amazing. So we're looking at amazing engineering talents, which you can find everywhere, especially in East Africa. Like people, they have the same kind of training, obviously, but it's different. Like in the West, you'd feel more theoretical engineers, and in East Africa, you'll find a lot of people that actually know how to build stuff and know how to build stuff fast, and know how to work with limitations, because that's also obviously a thing.
Yeah.
And then three, we're looking into, is there a existing 3D printing market? So India obviously has an established market, which is really growing. So that's interesting for us. DAR is a bit behind that. There are existing partners working with 3D printing, but it is somewhat slow. But that means there's a lot huge potential for growth. So those are the two markets we're in now. Obviously, we're going to look into setting up franchises in markets that are already established, like the bigger markets such as the US. And then the market that would be really hard for us to get into if there's nothing, no one interested in 3D printing or anything. So there are some countries in Africa where there's nothing except some sort of NGO project, which often is not really sustainable. So if you really look at the 3D printing for development, we've seen a lot of NGO type projects, which are 1-time, 2-time based, and it needs a big drive to really get there. And Reflow as a company, we're hoping to really support those local startups from our social impact side. That's one big social impact. We can help companies develop the microscope, set that up as a business. We develop the materials, help them with a lot of the stuff around that. But also that's market growth for us. So it's a win-win in that situation.
Nice.
And that's, I think, how best social enterprises work, when everything you do in the end is a win-win.
Nice. I think, 3D Hubs, I'm sure you've already chatted with them. They're right next door. Might be a good partner in this effort.
Sorry, I missed you there.
As in 3D Hubs might be a good partner in this effort.
We are already partnering with 3D Hubs. Okay. So setting up a partnership now. So yeah, I agree. They are really, really awesome.
Right next door to you.
Yeah, they are right next door to you, and they are great guys.
Yeah, nice. So we have Sasha. She's actually a student. So thank you, Sasha. I'm glad you enjoyed the course. So she's saying we're looking at two situations. One is 3D printing from a perspective of fixing production, or rather fixing supply chains, and maybe producing things that we don't produce typically in a volumes scenario. And some applications in 3D printing in developed economies as well. Actually, Sasha, in terms of, yes, there is a lot of application even in developing countries where they're looking at end-use parts as well, because here you can control and you have more variety of materials. and depending on how much capital you can put in, you can actually go for end-use parts printed out of metal or other alloys as well. Of course, I mean, great to share your observations. Do you have a, if you have a question around that, you can state that as well. So Jasper Ectorina has a question, perhaps you can answer.
We have not developed in France so far, but it'll definitely be a place we'd be looking at down the line. I know there's a big community there, so.
So we'll share Jasper's contact details when we finish the Q&A as well. So any other questions from our viewers? So Jacqueline has another question on Jasper. What is the most challenging part of working with recycled filament, and how much plastic waste is made per day?
So the most challenging part working with recycled filament or working with recycled plastic. There's no big challenge in working with recycled filaments. Once we got the production done, it is exactly the same as working with normal filaments. Of course, if we make PET, it compares to PET filaments. If it's ABS, it compares to ABS. So there's all different types of plastic. And working with recycled plastic, obviously getting it food grade, clean to go into the extruder is the biggest challenge. And the entire process around that is one of our main things we're developing. So obviously you don't want a grain of sand in your filament because it clog up your printer. So that's the biggest challenge. How much plastic waste is made per day? Like globally or in Tanzania, I think like, the numbers are pretty staggering. I know that at least only in bottles, there is 1.5 billion kgs that ends up in landfills each year. So that excludes the one that already recycled. If you take all the plastics, that's way, way, way more huge. If you go through any city in East Africa, you'll see it everywhere. It's being burned. So it's a really big problem.
So right now you're focusing only on PET, which is commonly found in the water bottles that we use for drinking water, right?
Exactly. It's easy to source. It's hard to make. So it's both challenging for us. So if we know we can make PET, we can do a lot of different materials as well. But it's easy to source. Like ABS, it's like different from a car bumper into a refrigerator.
Okay.
It has different chemicals, different compositions. So you can't just like take a refrigerator ABS, take a plastic, like a car bumper, and put it together because it'll be a mess.
Okay. So I think, yeah, controlling the quality of the raw material is perhaps the biggest challenge, but plastic bottles are all over the world. So if you can reduce some of those from going into the landfill, it's so much better.
Yeah.
Any other questions before we close the session and share Jasper's contact details again? Sasha has a question about government support.
I'll quickly walk. My battery's almost done. The government, they are relatively open. It's always hard working with governments in Africa. So in Tanzania specifically, we're working with the World Bank, and they're working with COSTECH, Ministry of Science and Technology. So they've been really helpful. In East Africa, try to go around government institutions or big institutions generally, because it always slows you down more than you can do. So, but we really don't need much government interference in these types of projects, which is why it could grow so quickly. You just need a good local makers and a local people to sell it to. You don't need like the government isn't that involved in waste collection, for instance. It is mostly private parties.
Okay. So Uzair has a question about 3D firms making it into Fortune 500 companies. I don't think any of them have, I don't know. I mean, the big ones are 3D Systems and Stratasys and X1. Now, of course, if you think of Autodesk is now making the hardware for 3D printers, so Autodesk certainly would be there. But of course, many of these firms had a significant drop in market capitalization all of last year when sort of the 3D printing hype subsided. And if you look at for example, stock symbols for 3D systems, which is just the 3 letters DDD, you'll see what has happened with Stratasys and these companies. But yes, I mean, several of the big firms, for example, HP is now saying their major initiative is going to be 3D printing with their, $100,000 plus printer, which is not too bad for the kind of capability they're offering. So many of the big, instead of the small firms growing big, I think many of the big firms have just jumped into this space. Jasper, any comments on that?
Yeah, I think there's a big disconnect between the Stratasys and 3D Systems and the companies that are really profitable and really doing well on the smaller consumer age, like Ultimaker.
Yeah.
Like the 3D Systems, Stratasys are just the old industry partners. They've gone really big from legacy, from patents.
Yeah.
And they have trouble actually capturing any new innovation in the market in terms of anything that goes to consumer side.
Yeah.
The Cube was a big failure.
Yeah.
The way Stratasys handled MakerBot was the worst. So if you ever want to get a good lesson into how to not deal with open source communities, look at Printer Legends and how MakerBot how the MakerBot community got screwed over, but MakerBot itself, of course, as well. So I'm not sure if 3 Systems are in the Fortune 500. I'm guessing not. And then 3 Systems had to cut out their Cube, so their consumer printer, because they couldn't just compete with Ultimaker, interestingly enough.
Yeah.
There's a big, Carbon 3D got a big investment by Google.
Yeah.
So it is a more than $1 billion company now. Obviously, that's not a Fortune 500 company, but in terms of in startup, you call a unicorn. So it's a company that's become a $1 billion company valuation within maybe 3 to 5 years. I think Carbon got there in 2 years or something like that.
Yeah.
So